back to our welcome back to our channel. Till now we have seen the terms used in the design. Till now we have seen the terms whatever we are going to use in the design of any structure. But we don't know where, already I said that we are going to find these terms in the code book or find the values related to the design in the code book. But we don't know where we are going to where we find those values in the code book. So for that we let us go through the code book at a glance. So for designing of any structure like rectangular beams, for rectangular beams the design procedure you are going to find in the annexure Z. In most of the code books annexure Z is going to be same. So in that you are going to find the values of XU by D calculations and moment calculation and mu limit calculation. So this part means that is nothing but G 1.1. So G 1.1 is going to represent the design of singly reinforced sections, and whereas G 1.2 it is going to define the reinforcement details or reinforcement details in the doubly reinforced section. In doubly reinforced section we are going to provide extra reinforcement. So that extra reinforcement we are going to represent with ASC, and D is nothing but effective depth of the section, and D dash is nothing but effective cover. So these two are the new words, new terminology words. So this is about the designing of doubly reinforced and singly reinforced sections, and sometimes we are going to consider the values of effective span for any section. We are going to define effective span for any section in two ways. The actual definition for effective span is clear span plus support width, means we are going to consider the clear span dimension of the beam plus center to center support width of the beam. So that is going to be the effective depth of the section, that we are going to consider in terms of beams, and slabs also we are going to consider the same effective span. And one more thing is that in effective span we are going to calculate using another formula also, that is effective depth plus effective span. So among these two values whichever is lesser, that will be considered as the effective span. So at last effective span is clear span plus 1 support width or center to center of the support width, and other one is clear span plus effective depth of the section. So among these two values whichever is lesser, that is going to be the effective span of the section. So most of the people will be getting confused with this effective span. So that's why I am repeatedly saying the clause related to this effective span. And one more thing is that if I don't know the depth of any section, while calculating the cross section details of any section, if I was not given any cross section details of any section, that is nothing but breadth and depth of the section, then we can calculate by using the IS code. So from clause 23.2.1 you can find the effective depth ratios for different types of beams. So for cantilever beam this ratio is going to be equal to 7, and for simply supported beam it is equal to 20, and similarly for continuous it is going to be 26 meters. So and these values are just applicable for the span only up to 10 meters, and if the span exceeds beyond 10 meters then we cannot consider these values. But if the span is below 10 meters or up to 10 meters, then only we can consider these values. And from the same clause of point B you can find one more point. So you can find one more point, that is nothing but for spans above 10 meters this value will be multiplied. See, for spans above 10 meters the values in A will be multiplied by 10 by span in meters. So this is the clause I have to follow for the beams which are exceeding about 10 meters. For spans below 10 meters or up to 10 meters I can directly consider these values from clause 23.2.1a. For beyond 10 meters I have to follow the clause B. So in the same way we can find the definitions for effective depth in page 36 or 23, clause 23. For effective span also you can find from clause 22.2. So you will be having the definitions for all these things. Like for spacing in the beam also we are going to consider it as 0.75D. Means minimum spacing in stirrups we are going to consider it as in the shear reinforcement, and whereas in maximum spacing it is going to be 0.75D or 300. So already I said that maximum spacing is 0.75D and 300. So among these two values, whichever is lesser, that will be considered as the maximum spacing value. So at last I conclude that these are the most important terms we have to know in the designing of any structure, and this is the basic about the terms. Basic terms we have to know before doing any problem or before solving any design. If you like my video, please share and subscribe.